The symbol of the U.S. dominance on the seas is its big surface fleet gathering around the aircraft carriers. Yet, since the Second World War, the silent heroes, submarines have been very important players of this game. Now, the U.S. Navy is preparing for the Second Cold War, with its new Virginia-class submarines. Thanks to its successful design and innovative technologies, they are a fearful opponent for naval rivals of the USA. As the weapon detective, we are investigating Virginia-class submarines. The Virginia-class was designed to replace older Los Angeles-class, which has been backbone of the U.S. attack submarine fleet since 1970s. It is effective in both oceans and littorals. The submarine can be used for anti-submarine warfare, anti-surface warfare, land attack, intelligence gathering, and special operation missions. Actually, when the Soviet Navy had changed the balance in the area of the submarines with highly capable Alpha, Akela, and Sierra classes, the U.S. Navy started working on Sea Wolf class in 1983 as the successor of the Los Angeles class. The USA planned to build at least 29 Sea Wolf classes over a 10-year period, but the number was reduced to 12 because of their high prices. The end of the First Cold War caused further reduction, and only 3 boats ever built. In 1991, the U.S. Navy started developing new submarine under the Centurion Study Program. As the fruit of this program, Virginia class is less expensive alternative to the Sea Wolf class. The submarine was the first U.S. Navy warships designed with the help of the computer-aided design and visualization technology. As the first of its class, USS Virginia was laid down on the 2nd of September 1999, launched on the 16th of August 2003, and commissioned on the 23rd of October 2004. First 4 boats, defined as Block 1, were built in 10 modules with each submarine. 6 Block 2 Virginia-class submarines were built in 4 sections rather than 10 sections to reduce costs. Different from their predecessors, the Block 3 submarines have 2 multi-purpose Virginia payload tubes. These tubes replaced the dozen single-purpose cruise missile launch tubes of Block 1 and 2s. The other difference of the Block 3 is their horseshoe-shaped large aperture bow sonar array. This sonar replaces the spherical main sonar array which has been used on all U.S. Navy submarines since 1960. The spherical main sonar array was air-backed. The large aperture bow sonar array, which consists of a passive array and a medium-frequency active array, is water-backed. In 2014, the U.S. Navy ordered 10 Block 4 Virginia-class boats. Thanks to experience comes from first 3 blocks, the new submarines can be deployed longer time between major maintenance periods. The latest version of the Virginia class is the Block 5. The first boat of this version, USS Oklahoma, was authorized for construction on the 2nd of December 2019. The Block 5 submarines will have an additional Virginia payload module mid-body section, so they will be 25 meters longer and 2,400 tons heavier than their predecessors. They will be able to carry 40 Tomahawk cruise missiles instead of 12. The U.S. Navy is planning to have 10 Block 5 Virginia-class to replace 4 Ohio-class nuclear cruise missile submarines which will be decommissioned in next 10 years. The Virginia-class submarines have 114.8 meters length, 10.4 meters beam, 6,390 tons surfaced, and 7,800 tons submerged displacement. The crew consists of 14 officers and 120 enlisted men. The submarine can reach 25 knot speed on surface and 34 knot speed underwater. It can launch Mk-48 torpedoes and sub-harpoon missile from its 4 533mm torpedo tubes. Each submarine is projected to make 15 deployments during its 33-year service life. The Virginia-class can dive 490 meters depth. There are many innovative technologies on the Virginia-class. First of all, they are equipped with photonic mast instead of a traditional periscope. This type of masts is already used on British Astute-class nuclear attack and Japanese Soryu-class diesel-electric patrol submarines besides the Virginias. the photonic mast does not penetrate the pressure hull. So, while the structural integrity of the pressure hull is increased, the risk of flooding is reduced. Thanks to photonic mast, submarine's control room can be located anywhere inside the pressure hull. While in the traditional periscope design, the control room must be below the sail. On the photonic masts of Virginia class, there are high-resolution cameras, along with light intensification and infrared sensors, an infrared laser rangefinder, and an integrated electronic support measures array. But this design has a serious handicap. The mast is the only exposed part of the submarine when it's submerged. So, an observer could detect the submarine's class by shape of its masts. For the Virginia-class boats, this is much easier, because the visual appearance of their photonics masts is so different from the ordinary periscopes. To prevent this handicap, the U.S. Navy decided replacing current photonic masts with low-profile photonics masts which resemble traditional submarine periscopes more closely. It is also considered that Virginia-class submarine will be equipped with the mast which provides 360-degree view without necessity of rotation. The 8 masts of the Virginia-class boats have been unified in a universal modular mast program. It means all masts' shared components have been maximized and some design choices are also shared. The pump jet propulsors of the Virginia class assure the performance of the submarine in both oceans and the littorals. They also make the boats more silent. The conventional blade propulsors produce steam bubbles because of frictional heat when they rotate at high speed. When these bubbles pop, they make noise. It is called cavitation. The pump jet reduces the risks of cavitation significantly. To reduce noise trace, the pressured hull and the sail of the submarine are coated with special materials. As you know, the hardware and software of electronic systems become obsolete in very short period. Because of that, the people changes their smartphones with the advanced models in a couple years, and the application are upgraded constantly. Likewise, hardware upgrades are generally carried out every 4 years, while software updates are carried out every 2 years for the submarines by the U.S. Navy. So, the designer of the Virginia class preferred open system architecture for sonar arrays aboard boat. Thus, new hardware and software can be inserted rapidly and easily as they become available. It is planned to replace electro-hydraulic systems for control surface actuation with fiber-optic fly-by-wire ship control system. One of the other planned innovative upgrades for the Virginia class is the high-energy laser weapon installation. Some surface ships of the U.S. Navy are already equipped with this kind of weapon for test purpose. If the Virginia-class submarine would have laser weapon, it could change the future of the anti-submarine warfare. The modern submarines are very capable opponents of the surface combatants. They are hard to detect and deadly with sophisticated sensors as well as long-range torpedoes and missiles. So, today the main submarine hunters are not destroyers and frigates, but they're helicopters. Because the current submarines do not have any effective weapon against their target. But a submarine which has a laser weapon on its mast could shoot down a helicopter while it is still submerged. At least it would force the air target to cut its dipping sonar and flee. A high-energy laser weapon needs powerful energy source. The 30-megawatt S9G nuclear reactor of the Virginia-class boat can provide this energy. With its technological achievements, the Virginia-class will affect the future submarine design. It is estimated that the last submarine of the class would be decommissioned in 2070s. So, these boats will be main U.S. actors in underwater front of the Second Cold War for next 50 years. Thanks for watching our new video.